Mining for gold here in SolidWorks templates. Really stems from a customer visit of recent. They were looking to default to their own custom gauge table every time they initiate a new sheet metal part. So let's take a look how that's done. Basically, we're just going to kind of start a sheet metal part in SolidWorks. If you've never done this, it doesn't really matter what this looks like. Here just to show you, I'll just whip something out. Whatever. I'm not going to dimension it because it's not important. And here I'll use the base flange command. And again, doesn't really matter the size and things that you put in here. But the main thing we want to do here is we're going to select gauge table. And I just create a little custom gauge table here, stored that in a directory accordingly here. And you can pick your gauge and radius and things like that. And you can even do other things here, like for instance, maybe we want to not use the K factor that's specified in the gauge table, but in this organization, maybe we use a particular bend allowance or something. So we'll key in that too, and that'll be captured as well as part of our template. So I'm going to accept this with our gauge table and custom bend allowance, and basically all I'm going to do is get rid of it. So I'm going to just come right in here and delete. Let's just delete the sketch as well. We'll accept that, and we're ready to save as a part template. So I'll just do a file save as here. We'll save it as a part template. Let's just put it in a directory here, and just to show you here, we'll just name it number 3 here, and hit save. And we can go ahead and close, and let's test it out. So file new, let's pick our gauge table 3 template and give it a go. Let's just create some new geometry here. And just to show you, this can be totally, maybe we just do a rectangle this time just to show you. And sheet metal and base flange. And if you take a look here, it's using my custom gauge table automatically with the appropriate gauge and bend allowance as well that I specified. And that's basically how you do that. You just basically create your kind of a dummy sheet metal part with the settings you want, delete it, and save a part template. And it's actually capturing those jump starts from the base flange command in this case in your part template. Little caveat to this in this case that we find out at the customer is that for instance, I did it here. If you take a look at my gauges, they're not in numerical order. I got 9 gauge down at the bottom. And the reason for that is they also said, hey, 75% of the time we use 10 gauge or whatever it was. And, but occasionally they use 8 or 9 gauge as well. And this is just a little SolidWorks faux pas here. I think it's always going to default to whatever is first in your gauge table. So if you actually take a look at my gauge table here in Excel, all I did was just move the 9 gauge down to the bottom of the list, and that way every time they initiate a new sheet metal part, it also will default to 10 gauge in this case. So just a little caveat to that that you can do, and yeah, that's basically how you do that. Just keep in mind, this is if occasionally you do just a generic K factor, maybe you're not using a gauge table, whatever it is, sheet metal wise, you can capture any of those jump starts in your template. Another one would be sometimes we use convert to sheet metal. Same is true. Just kind of build a dummy part, use convert to sheet metal. Set your settings using a gauge table or whatever you're going to do accordingly, and then just delete that feature as well. And you can create multiple features and delete them, and it'll capture all those together in one nice part template for you. So just a few tips for you, some things to consider, and continue to mine through other features that you like in SolidWorks, and yeah, you'll be able to capture all those properties in a part template. Here I just got a dummy block up just to show you. Here I was showing you sheet metal features, but really this could be anything. For instance, if you want your hole wizard to default, we always use counterbores, whatever. Um, use the counterbore tool, set it to the type you like, and that'll be captured as well as part of your template. So just keep that in mind. So that's something you can do. I have noticed here fillets is usually a big one that a lot of people would do. Um, that like to do fillets or draft angle or chamfer, that kind of stuff. For some reason, 2012 SolidWorks doesn't seem to want to capture that. So kind of your workaround here is just adjusting your spin box increments as well, which this is a system option, so it's not really something you can capture in a template. But the spin box increments here, if you've never really adjusted those, is basically anytime you see that tick box, whether it's a fillet command, extrude boss, extrusion depth, those types of things. And this is what those will default to every time. So I'm gonna have to play around with that a little bit. If you have a weird fillet size, you always like it to default to that you don't want to set your spin box increment to. But I did notice for some reason in 2012 SolidWorks it wasn't capturing that. So, but other features, yeah, go to town, mine away, and make some really rich templates for your organization. Enjoy.